Hello, my name is Alexandra or Sandra Cannon, and my student number is C20450764. And in this video, I'll be explaining the code I used to create my first IOTs assignment. So the objective of the assignment was to pick a random sensor and then to create a system using your knowledge of IoTs and Bluetooth to use the sensor and to output what it senses onto both your laptop and onto your phone through BLE Scanner. In my case, I received the BMP280, which senses both temperature and pressure. So I had to use the data sheet for the BMP280 to find out how I can transfer what is being read onto the sensor, onto my phone, and onto my laptop. So here's the BMP280 datasheet. This datasheet contains absolutely all the information about the BMP280 that might be needed. The two parts I used probably the most were here on page 22, where I have the code of to how to calculate the pressure and the temperature for the BMP280, and also the memory map and register descriptions, which describes where all the information is held, aka their address, and how big, how many bits it is. Here is the setup of the circuits for this assignment. The sensor and the microbit are connected through many wires, and it's kind of hard to see. But the sensor is receiving an input of 3 volts and it is grounded. And it is also connected to the microbit through the SCL and SDA ports. So here we have the code for this assignment. I'm first going to go through the mydevice.c file, which reads and prints from the sensor the temperature and the pressure. Here is the myDevice read temperature function. From the datasheet, we know that the information transmitted from the sensor to the computer, it comes in 3 different parts. So in the middle of this code, you can see it calling onto those registers on the sensor for those 3 parts. And that is then converted into an integer that we can work with and calculate with. From the datasheet as well, some code was taken to actually print the temperature in Celsius. This outputted output of Celsius multiplied by 100. So for ease, I divided it by 100 and that will output the actual temperature. So if it's 22 degrees, it will output 22. Here we have the myDevice read pressure function. This was created similarly to the myDevice read temperature function, where a lot of my information came from the datasheet. So the exact same as the temperature, it's read from 3 parts. And in this part of my code, I read those 3 parts from the sensor. And then I create it into an integer using bit shifting. This part of the code as well is from the datasheet, calculating the pressure from the information that's read from the sensor. Here I converted into hectopascals and I divided by 100 just as I did before in order to get a realistic answer. At the end of the file, the myDevice read calibration data is found, and all this information is also found from the datasheet. I then would transfer the names of each of these functions into my header file, which you can see here. It is a very short file, but it just has all the names. And in the main, they're all included up at the libraries at the very top. At the beginning of the main, in order to set up the Bluetooth, I created characteristics using the skeleton file and the IOTs module, where I replaced the ABCDEFG with my own name. So for this case, here it is my temperature, and this one is for my pressure. Here's where the service is defined. In this case, the service is going to be defined as 9,000. Within the service 9,000, my temperature characteristic is going to be called 9,001, and my pressure characteristic is going to be called 9,002. A large chunk of this code is from the BLE minimal code found in the module, and that's how the code knows to connect to my phone through Bluetooth. In the main function, a lot of error messages are created in order to make sure that everything's working. Within the while loop, there's 2 printf functions that will print onto my laptop screen, and they call the myDevice read temperature and myDevice read pressure from the myDevice.c file, which will then output the temperature and the pressure. Similarly, the my pressure and my temperature are equal to their function from the my device file. Those two variables are related to the characteristics at the top of the code, which are then going to be using the outputs of the function and sending them to my phone. There is also a 1 second delay in order to not overload me with information. This is the code now working in action with the circuit. So here I just ran the code using West Flash on Linux and the code starts working. First I begin with some results saying that everything is working right. Temperature and pressure are being recorded as they should. On my iPad on BLE Scanner, I find Sandra's microbit and click into it. There I find the service number 9000. When I click within it, I find 9001 and 9002 as I defined in my code. As I press into each characteristic, an output appears on my port registering that an output has been made, and it also appears on my iPad in hexadecimal format. To ensure my sensor is working, I warm up my finger and put it onto the sensor, hence increasing the temperature, and that can be seen on the screen. Thank you for listening.